Okay, so this video is going to show a different way to think about factoring using what's called an area model. Um, and this way helps us get sort of a visual representation of what we're doing when we're multiplying, and then we use that visual representation to think about what we're doing when we're factoring. So just to make sure that we're clear, when we're multiplying two numbers, so for example, if I'm multiplying 2 times 3, I'm taking a 2-unit long piece and I'm finding the area of a 2-unit long piece and a 3-unit long piece, right? So I've got 2 units long, 3 units long, and the area of those is 6 square units. So multiplication and area are very related. They're interchangeable when we think about them. We talked about using it with the distributive property. We talked about a block that was x units tall and another length that was, say, maybe x plus 7 units long. And we talked about how we could think of this as an x squared block, and we could think of this as a positive 7x block. And so we could say that the area of this rectangle would be x squared plus 7x. Or we could think of it as an x unit tall block distributed across an x plus 7 unit length. And if we distributed that, we would have x squared plus 7x. Here we're going to use the same idea, multiplying a binomial by a binomial. So I've got an x plus 3 unit length, and I'm going to multiply it by an x plus 5 unit length. And notice I'm going to end up with 4 areas or 4 terms when I do that multiplication. We've talked about that as well. So x times x would give me x squared. This would give me positive 3x. This would give me positive 5x. And this piece here would give me positive 15. Now, of course, these two blocks have like terms in them. So when I write out my 4 terms, x squared plus 3x plus 5x plus 15, I know that I'm going to combine my 2 like terms. So my 4 area pieces look like they're only 3 pieces, but in reality, that middle term, that linear term, is a combination of those 2 boxes or those 2 terms. When I factor, I'm going to work my way backwards. I'm going to start with the area of the block, and I'm going to find out how long are the 2 lengths that were multiplied together to give me that area. So let's take a look at how we're going to use this area model to take this area and find out what are the 2 lengths that we multiplied together to get us this area. So if I remember that this is the area here, n squared minus n minus 12. So 2 things were multiplied together to give me the n squared, and 2 things were multiplied together to give me the negative 12. But then there were 2 terms that were combined or added together to give me this central b term. So when I'm when I'm trying to find these lengths, I need to undo this addition that gave me this centralized b term. I need to find out what are the 2 things that were added together to give me this b. In other words, I know that whatever these 2 numbers were that were added together also multiplied together to give me negative 12. So I need to find those factors of negative 12, which is that a times c that we talked about in class. And I need them to sum to the b term here, which is negative 1. Okay, so I need 2 factors. So if I think about the factors of negative 12, I'm going to have 2 factors, 2 things that multiply together to give me negative 12, but that sum or that add to negative 1. Okay, So let's start at the beginning. Let's find out what are these factors of negative 12. Well, 1 times negative 12 would give me negative 12 when I multiplied. But when I add, it would give me negative 11, which is not negative 1, so that doesn't work. I could do negative 1 and 12, but that would give me positive 11, which also doesn't work. How about 2 and negative 6? That would multiply together to give me negative 12. But when I added those would give me negative 4, which isn't right. So I could switch it. I could do negative 2 and positive 6, and that would give me positive 4, which still doesn't work. What else goes into 12? Oh, 3. 3 goes into 12, so it would be 3 and negative 4 to give me 12 when I multiplied. And if I add those give me negative 1. Look at that. These are the two terms that multiplied together give us negative 12 and added together give us negative 1. In other words, this term must have been 3n plus negative 4n before it was combined to become negative n. So our original 4 terms of our polynomial were n squared plus 3n minus 4n, or plus negative 4n, minus 12. So if we look at our 4 area spaces, we know that the 4 terms that go in here are n squared for the first term, positive 3n, negative 4n, and negative 12. So these, again, 2 blocks were the ones that were combined or added together to give me that b term. So now I can take a look and see, well, what did I multiply by what to get this area? Well, what times what would have given me that n squared? And that was n times n. And what times what was multiplied, or actually I know what one of the terms was. I know that I multiplied n times something to give me 3n, so that must be positive 3. And I know that I multiplied n times something because this length is n, so something would give me negative 4n, so that must be negative 4. And I can now check, is negative 4 times positive 3 negative 12? Yeah, that's true, so that checks out. So in other words, my 2 factors, my 2 terms here were n plus 3 and n minus 4. I can further check by multiplying them back together. So I would distribute it back. N times n is n squared. N times negative 4 is negative 4n. 3 times n would be positive 3n, and 3 times negative 4 is negative 12. So combining those back together gets me back to the start. So I'm going to go ahead and do one more example. If you want to follow along with me for this example, you're welcome to. But if you think you're ready to go ahead and do your homework, you can go and get started with that. So one more example, just to make sure we understand. So remembering that this middle term here, this b term, negative 9x, is really the combined combination of 2 terms that were added together. We want to find out what those 2 terms are. And we know that they multiply together to give us positive 20, and that they add together to give us negative 9. So let's find the terms that factor to 20 and that sum to negative 9. Okay? So we've got positive 1 and positive 20, which would give us 21, so that won't work. Or we could do negative 1 and negative 20, which would sum to negative 21, which also won't give us negative 9. Well, what about 2? We could have positive 2 and positive 10, which would sum to 12, so that won't work. Or we could have negative 2 and negative 10 would give us positive 20, but that would give us negative 12, so that won't work either. 3 doesn't go into 20, so what about 4? We could have 4 times 5 gives us 20, but that would give us a positive 9, not a negative 9. So what about negative 4 and negative 5? Look at that. That gives us that -9. So that's our combined term. In other words, we combined -4x and -5x to get -9x. So the full 4-term polynomial was x squared minus 4x minus 5x plus 20. This is the area that was gotten by multiplying two binomials. So let's do it. Let's find out what that area becomes. Minus 4x minus 5x. Well, x times x would have given us the x squared. And x times what gives us -4x? Well, x times -4 gives us this area, -4x. And x times what gives us -5x? Well, that would be -5. And we can check by saying is -4 times -5 positive 20? And indeed it is. So x minus 4 times x minus 5 are our two binomial lengths that when multiplied together give us that area. And we can of course check it by multiplying it back together. Okay, I'm pretty sure you're ready to go, so enjoy your homework, and I will see you on Monday.